Welcome back. My name is Matthew Woodford, and I'm discussing what makes a robust process. In my first session, we discussed what is a world-class level for robust process. What is a robust process definition? Then in my second part, we looked at using OEE as a measurement of overall equipment efficiency. In this session, we're going to look at some of the quality indicators tools that we can use to help us maintain our 85% in our OEE measurables. So having explained that in order to achieve 85% or more in OEE, apart from equipment uptime or availability, it must be consistently producing good parts. That was the other part of the description of what is a robust process. We need to have consistently good parts. So how do we go about defining what is a measure of consistency? Should you have already done the course on Statistical Process Control, SPC, this is where all those good things that you learned start to come into play. The feature we're going to understand here, or talk about, is process capability. In everything we do in life, no matter how hard we try, there is always variation. Sometimes variation is good. In manufacturing, variation is not good. So everything we do, everything we measure, everything we machine, everything we assemble is always done slightly different to the previous one. There is always variation, even if it is small. It is still variation. In manufacturing, we need to control that variation in order to maintain a stable process. A stable process is a predictable process, and using statistics, we can predict how capable and stable this process is on an ongoing basis, that there are no special causes that disrupt your capability. If you are designing a new process or adding additional equipment into an existing process, you need to conduct a capability analysis. Nearly all of the big problems and tasks and challenges I've been asked to assist with in resolving quality concerns at many and various production lines around the world, they always come down due to the lack of APQP, run at rate capability trials. If people had done and followed an APQP and done each of those elements, one of those key elements is run at rate capability trials. When purchasing equipment, it is imperative that this measurable is declared in the tender process to your prospective suppliers. They must demonstrate the capability of the equipment as part of the equipment buy-off procedure. Believe me, if you don't ask for it, you may well not get it. If you ask for it afterwards, most machine builders, quality machine builders will say, oh, well, yes, we can do that, but that wasn't asked for in the initial quote. This is going to cause initial delay and additional cost and blah, blah, blah. And then you have to go back with your tail between your legs and say to your bosses, the equipment's not capable. We didn't ask for it. Now we've got to come and do something different. We don't want to be doing that. So just as a sideline, make sure when you go out on machine tenders, you have all the expected quality levels of approval for your equipment, for capability, for reliability, for technical availability. They all need to be declared. So, process capability. It's measured using the CP-CPK and or the PP-PPK index. However, should we want to look at machine capability excludes the fixtures, the tooling, the process. Then we can do a machine capability, which is an MK or MPK. But here we're just looking at the process capability, CP-CPK, or known as PP-PPK. If you've done the SPC course, you should understand the difference between the two. So again, with our data collection sheets, we need to collect the measurement results needed in order to calculate the potential process capability, the PPK. The accepted minimum standard for a PPK analysis should achieve a PPK of 1.67 or better. However, should this characteristic under study be rated a critical or significant characteristic, the customer may well, within his rights, request that this particular operation or this particular characteristic on this machine or equipment must show a demonstrated PPK of 2 or better. So if we understand what we have to achieve, what the target is, we can go about defining it, measuring it. So if you have done the course or you are familiar with capability, you would know that the voice of the customer, we call the VOC, divided by the voice of the process equals our PP. So, what is the voice of the customer? What is the voice of the process? If we look at the tables, if we just first want to quantify what our PP or CP values mean in real terms, if we are looking for a PP demonstrated value of 2, then that basically gives us a standard deviation of plus minus 6 standard deviations, which equates to our rejects parts per million as 0.002. So for every million parts produced, there is a probability that you can't measure, 0.002 reject. It will just have to be several millions before you can add those 0.002s together to get your one part. But that basically is saying that we are at 0 defect. That is what is called or terminated your Six Sigma 0 defect philosophy. Another quantified target for robust process then is our CP, which is ongoing calculated when you are running production, must equal 1.33 or more. And or our PP must equal or be greater than 1.67. It may be 2 should your customer require it. But for a robust process, which is what we are trying to discuss, our CP must be equal or greater than 1.33, and our PP value must be equal or greater than 1.67. That tells us we have a repeatable process. So now, if we have achieved those figures, we have a capable process. But is it accurate? Remember, if you've done this course, that CP/PP determines the capability without measuring to target. It is just saying, yes, this process is capable. We haven't declared if it is accurate. Your CPK/PPK measurement capability to target value, or your X bar. So if we look at our CPK and our PPK, that will tell us if we are both capable and accurate. That is it for this session. Next, we will look at maintaining a robust process. Thank you for listening. Talk next time.